So this is ELN 133. Students are reviewing the quiz for 20 minutes. They're helping each other out, working on work study groups. A students paired up with the students who did not do that well on the quiz. Let's bring up this. Oh, come on. Give me a break.
That's good.
Yeah.
In these diagrams, this is the AND gate and it's an 08.
You put 00.
Well, I put the 00.
Yeah. See, it's 4 points. It's 1 point for each reference designator and 1 point for each part number. And then this is 1 point for each node connection. 1, 2, 3, 4, 5. That's how I add everything up.
I realized that. I just
actually should have given you
one.
I should have given you 1 point off for this, but I gave you a break and just gave you a half. So, because I mean, you pretty much perfected everything except for that.
Yeah.
But I counted off on everyone else too. So.
I understood it. I just
you just mixed
confused
up.
Apparently.
And I knew you did. That's why I gave you half, because I knew you had it right because you read it right. So that's fine. Then you have to know where the hell it goes. All you have to do is put that in the wire. Sorry, you guys have to do this quick. We have to be more organized. And if I give everyone a solution, you guys will have the answers. How are you guys on the solution? Is there one you think you know what issue?
Yeah, pretty much. I didn't realize you switched these around.
How about you guys? You did pretty good. Oh, that would be hard, yeah. Okay, yeah, get it calculated.
You know what? This
Oh, okay. That's probably not a good example to have, then,
I
is
got
it?
it. I got it backwards.
That's why, okay.
I mean, kind of.
A lot of people actually got it, several people got it backwards.
Really?
About 3 people. Okay, guys, we're done with that, so we're going to go ahead and work on the next lab. If you guys don't mind migrating up this way. Now, if there's any other questions, you can ask it after classes, or we have a 30-minute break. So right now, we're just going to go over a quick little lecture and lab. Yeah, just in your seats. Yeah, just in your seats. That's right. Just go to your seats. So today we're going to have a lab 3 in your books. If you guys go ahead and get your lab books out, and actually I would be looking at lab 3 right now as we're talking about this. The prerequisites for this is chapter 2.5. So when you're doing your lab today, you can kind of look at 2.5 in your textbook. And we're going to go over those slides really quick. So we can use logic gates as enables. So we call that, sometimes we call it gating. The word gate would mean that when you use an AND gate or an OR gate or any other type of gate to control a pulsed signal or a clocked signal, we call that gating. Kind of like a gate controls, what goes in and out. That's the same type of analogy. And the logic gate inhibit is the same sort of thing. It's like gating. It inhibits the signal to come out. So it's the same kind of concept, but just a different terminology. So let's look at gate, a way to inhibit a pulsed signal on B here. So if we have a clock signal on B, and we know the function of an AND gate is such that you have to have a logic 1 on both inputs in order to get a logic 1 on the output. So if we force one of the inputs, which is A, to 0, then nothing will come out on the output, because A is always 0, and you need a 1 and a 1 to get a 1 on the output. Conversely, if we have a 1 on this, which we call the inhibit, this we're going to call the inhibit line. If we have a 1 on A, then whenever B goes to a 1, then that signal is going to come on the output. Okay? Because 1 and 1 gives you a 1 on an AND gate. However, a 1 and a 0 is going to give you a 0. So what you wind up with is a waveform. Okay, now if we translate this, what we set up here, into a waveform format, then what we say is A is 0 this entire time, which is indicated here, but you have a pulse on B, and so the output Y is going to always be 0, and we call this inhibited. When A goes to logic 1, now every time the B clock goes high, then we're going to get a 1 on Y. So you can see that the waveform for Y and B are different. And you can see that really the waveform on Y is controlled by the signal on A. So a practical circuit for this would be to have a pull-up resistor with a switch. When the switch is open, of course, this is pulled up to 5 volts, which is logic 1. And the pulse generator is here, so you're going to get a pulse on the output Y. However, when you close the switch, Ohm's law says that, and Kirchhoff's voltage law and all the other laws of AC or DC circuit analysis say that because this switch has a much lower resistance than the resistor, because the resistor is going to be about 1K or 10K or something like that. Since this has the lowest resistance, then the switch is going to win, because you basically have a battle here going on. This is trying to pull up, this is trying to pull down to ground. Resistor tries to pull up to +5. The switch tries to pull down to ground. Since you set the resistor very high and the switch resistance is very low, like 1 milliohm, or then when the switch is closed, it's going to win, and it's going to force this line to be 0, which now is going to inhibit this pulse from appearing on the Y output. Any questions on that? Because this is the lab basically that we're going to be doing today. In fact, if you look, thank you. I think that's really all we need to cover. Here's the lab. So you can reference page 2.5 if you have any questions. Now we're not going to do this entire lab, but there's some reading here that I want you guys to do actually right now, and then we're going to work on, I think, just 1 through 3 is all we're going to work on. Okay, so I'm going to leave it right here. But what I want you guys to do right now, I'm going to turn the lights back on. I want you to read all this information right here, and I'm going to go back to the back and set up a demonstration. first thing, we're going to basically draw we're going to build the circuit. Figure 1, we're going to answer the questions on 2, 3, and we're going to stop. So what we're going to do, not now, but we're going to grab one of these boards, grab a couple of these wires, connect it to 5 volts, put this in the middle, turn it on, and so we'll just keep it 5 volts for digital. Grab a 08, which is an AND gate, plug it in here like we did last week, connect the power, pin 14, ground, and 7. You'll need to take a resistor and pull up on pin 1, because that's the input to this AND gate. Okay, this is going to be the control signal. We're going to have a switch here on this input. So we're going to pull pin 1, input to the AND gate, and pull it high. Now you're going to configure your switch so that when you switch it in the right direction, blue is the output. So when you move it in the right direction, it's going to inhibit. So yellow is our clock from the clock generator right here. Okay? You can see how that works, right? Now, a lot of times this will be, actually, let's call it clock gating. That's what the Pentium processors do actually when they go to low power mode, is there's an AND gate in the microprocessor. A section of the microprocessor will gate its own clock, which means it'll do this sort of thing. Your clock won't do anything. It just kind of, without the clock running, it saves a lot of power. Okay, so then after you do that, then you take this function generator, set it up to any random signal. Here I did 7 kilohertz. What you have to do is get one of these cables. This cable has a BNC, this is called a BNC cable, and then you have just some clips on the end. I want to connect it to CMOS CPL. CPL means transistor logic. It was the original standard. It's the 0 to 5 volt standard for logic. And then CMOS, they're different levels. That's what that is, 0 to 5. Digital signal. Output here is more of an analog signal. You can adjust it higher or low. You can do whatever you want. But this one's always going to be a pulse, square wave signal, 0 to 5. So for digital class, you're going to use this. For the other DC circuit analysis class, you're going to use this one over here. Okay. So what you do is you set that up. You ground the black end to your ground plane. Now I use the blue bus as the ground plane. I use the red bus that goes all the way across as the VCC, plus 5 volts. Okay, now the first, before you do that, so now you're going to turn on this instrument. This is the oscilloscope, and I know you guys have used this before, but it's just a quick tutorial. Is the way you work this thing. The first thing you probably want to do is turn this on, connect these two together, and see if you can get anything on the output. That's one of the first steps. You think you've got it built. So all you do is just connect, this part. Okay, this is called the witch's hat. They call it. It comes off. It's used for probing, but what we're not going to do is we're not going to do this. Stick that in there because as soon as it gets bent over, that's $200 probing comes to the body. Okay. And we're also not going to do this. Take this and flip it on something and then jerk it around like that, because then you just get this. Another thing with these, there's a little knob on here. See that little switch? This has to always be on 10x. If it's not on 10x, you can change it here to 1x. We're not going to do that. We're going to always have it on 10x. Okay, because that's the high impedance. That helps you with your high impedance. So if you're getting a wrong reading, if your value was really high, then that means this is set wrong. Okay? You got a signal that's like, oh, that's 50 volts instead of 5 volts. That's what's wrong. Okay, so we'll just connect it here. So this will go to your positive, this will go to your ground. And these are not isolated. This ground is, all these grounds are connected together. So these are non-differential probes. You can't really measure differential signals. it's going to be. So now you can see this yellow signal. Now these are color coded, of course. This yellow signal goes to this yellow button, which goes to that yellow waveform. So it's really easy to use. Now you can see that if you change the frequency over here, and you change the frequency on the scope, then you know that it's working. If I put this switch, same thing happens. They're following each other. Now when you turn this on, the first thing I do is turn this oscilloscope on because it takes about 3 minutes to boot up. Once it boots up, I would hit the default setup. Default setup, and show you what happens. It puts it into just standard mode. Okay, that's what it's going to look like. Now, one quick and easy cheater way to get this thing to work is connect this. Put this about on put this on a 10, maybe a 10 kilohertz signal. So you select 20K and you set this to 10. Over here, the frequency here, this tells you the maximum frequency that you can generate with that setting. It doesn't tell you the actual. You put here 20K is the maximum, and you can go up to 20K. Okay, it's 22. But you can go down to 10. Now, what we can do here, just to get you guys past this, because we're going to learn more about this in ACES right now. So today we just want to get it done and back. So hit auto set. You hit auto set. It does all the hard stuff for you. Now you got your nice wave. Now, when you go to add your output wave, okay, so once you get your input signal set up, what we're going to do is we're going to see the output. So you need to have another waveform on the screen because we want to see the input and the output. So take the blue probe and you connect it to the output of the AND gate. This is output Y, output Y, output of the AND gate. So what I would do from that is just put a little jumper wire on the output. I wouldn't try to flip it onto the lead itself. It's going to short it out. And in fact, I would make yourself a ground clip as well. Ground clip, so that this goes to the ground and you can put this to your scope. So notice that I've got 2 ground clips. I've got an input red wire and an output yellow wire. Those are the 4 wires you need to have to get to your system. So put the ground clip on the green. Here, the blue one on the output, and then you have to turn the channel on because these other 3 channels by default will turn off when you hit the default setup button. Default setup makes it so that someone previous to you, they didn't have some weird settings in there, so it just clears all that information out. You just hit the blue button to turn on the blue probe. Just hit it one time and that's it. If you want to get rid of that menu bar, just hit menu off. Now, what you're going to have to do is notice the piece down here, the magnitude says 1 volt per division. It says 1 volt. Well, we're looking at a 5 volt signal, so you're going to have to turn the knob under the blue signal to the left until it says 5 volts per division. And you have to do the same with the yellow. And you can see that those were hidden because that was right on top of that. So you have the position knob. So you really have 3 buttons for each channel. You have the position knob is above the yellow. It's above the colored button, yellow or blue. And if you move that, notice how it moves it up and down. Okay? That's the horizontal position. Over here it tells you what they are: position, menu, and scale. Now, what does this knob do? This is called the scale. What this does is it shrinks it. You make it bigger. Smaller. The actual amplitude of the signal. Okay? Really what it does is it changes the division, but for you it makes it look like the amplitude is different. But really it's the same amplitude because notice that this says 5 and the signal is 1 gradic, which means 1 square. So square is 1 gradic. And if I turn this scale knob, notice that this goes to 10 volts per division. Square. But it's only half of the square, so that still means it's 5 volts. So it tells you the same answer. still read the amplitude off of the oscilloscope by looking at the volts per division. So I'm going to put that on 5. And now you have everything set up. If you want to move the blue signal or output, then you can move the position knob right above the blue button. And then you can test it with. So that's what we want to get to. So really today's lab is learning how to use an oscilloscope for the first time. Learning how to use this. We've already learned how to use this. We're really learning how to use these two instruments for the first time. And we're relearning how to wire things up. We're learning how to wire circuit up. We're reinforcing that concept. Introducing two new concepts. Okay? So
You want to do the rest of the screen, line in that diagram, the red screen, maybe.
you don't have to know. You'll be lucky to do that one thing right there. It'll be out of time. Unfortunately. Yeah.
I told them, I said, I didn't learn the answer to that one times 2 because I didn't know where to stop.
You can have it.
Yeah, I didn't know where to stop.
What did you talking about?
I don't have it right now because I didn't know where to stop. I didn't know where to stop.
Oh, just 4 digits.
Right.
4
I
places.
didn't know where to stop there, but I have.
Go ahead and write it out. Yeah, go ahead and write it out. Hey, I don't think I got the other quiz. Oh, Benjamin. There it is. Benjamin, did you get a handout? I put one over there.
Yes.
You did get it? Okay.
I'm just going to put what I think it is because, like I said, I'm confused.
Yeah, go ahead. Well, part of the purpose of giving you the quiz is to figure out what concepts you know and what concepts you don't, and then we can work on it with you later.
Right, because the homework that I had from last Wednesday, that last section of multiplying times 2, I just didn't understand it, so I couldn't get that done. But
Okay.
I did. I was working on it, doing what I could do with it.
I think next lab or next class tomorrow we'll try to set up a study group. If you can remind me.
Next
Tomorrow.
class?
Yeah, tomorrow.
Tomorrow, okay. no
Set up a
problem.
study group. You can use anywhere between 1 and 10K or 100K. It doesn't really matter. Something above 1K. I would not use 1K because everyone uses 1K. Use something other than 1K.
And,
1.2, 10, something like that.
the homework that I missed, well, so I don't fall behind the rest of the week. Would I be able to get all of that done, the CAD and stuff like that this weekend? Turn it in for a lesser grade on Monday?
Half grade. Yeah,
I mean,
it's
half grade's better than nothing.
Yeah.
As long as I can get it done.
Yeah, it's everything's on Moodle.
Okay, all right.
Yeah, everything's on Moodle.
Thank you.
Yep.
Turn it in to you on Monday.
One of them you submit online. Actually, the last EagleCAD thing is you submit it online.
Yeah, Chris was telling me that.
Oh, okay.
You builded
Just do that and submit it online to me.
just
Yeah.
that one?
Well, they're all building up to the. That's what the entire thing is just that.
Okay. So
We're just doing it in steps.
So watch the tutorials and then do the
Yeah.
lesson 12.
Yeah,
Okay. Or lesson 11.
all the way up to 11. Yeah.
copies of the lab? The lab? I saw a copy over there. So I have it for a hard copy for my personal.
No,
records.
I have solutions that I wrote out. That's what you saw.
Oh, okay.
I don't actually know where it's at though. Did I leave it over there?
Yeah, it's still over here.
Oh, okay. Yeah, that's my solution. And of course, if any of you want to reference this demo, you can come up and look at it.
This right here. No. We got some short wires over here. Having fun today?
Yeah. How about you?
No, I'm still tore up from the drive.
Yeah.
That is one hell of a drive, I'll tell you that. 2,750 miles. Alright, we only need blue and yellow.
I'm going to try to put this on here just for reference.
Yeah, this. I like those sticks. No. Alright, you have a resistor wired in, right? The power. Now, wait a minute. Alright, so it is. Where's the resistor? Okay. Alright, well, now let's line this up. We have a logic switch for the power, and we have the logic switch. So you need to go from power to the switch. You want me to hold it?
No, it's okay. I just want to get a picture of the oscilloscope. Okay, that's good.
Just get a reference from that. That's it. There's a small one. We'll use this one. This one straight from the ground to the side of the switch on the top. Straight from the ground. Oh, we might want to. This might be helpful to have it tonight.
If you guys want to add the LED, that's perfectly fine. If you want to add the LED, I would say if you want to have the LED blink, you need to set the frequency like really low, like 1 hertz, so you get a 1 hertz blink. But I would only do that if you're successful with getting into the oscilloscope.
5 volts. 5 volts. 2 and then 1
Y'all just looking.
Kind of. 5 volts per division. That'll be a good signal right there once we get in that.
Let's go. Okay. Alright. Thank you.
Let's see here. He's got the blue one hooked up to ground. To power going to the switch. So power going to the switch? I don't see that's going to the switch. So that's this is for. That goes to the pro. Right. That's what I'm about to do. I know we don't have everything else hooked up. I want to hook up the probes. Why is that? That's going to the front. That's going to the front. That's going to the yellow. That's going to 3 is going to the blue. 2 is going to the yellow. Alright, so this one's going to the blue, right?
Yeah, I forgot about that. Yeah, the scale knob is.
Alright, so 3 runs to blue, but 3 also runs to ground.
I have to show each person individually because it's weird to show you that one. Oh, actually, what I told you. Oh, no. What I told you to do is hit auto set. Remember, I told you to auto set.
Keep this out of the way. Or just put it on the ground over here.
But if you hit auto set, you won't need to use that.
This is going to 2, right? We got another probe we got to put on 2 though too. And then that runs to ground also. This going to power, right?
Oh, that's not in there.
Going to ground? I have one going to ground. They're both going to ground. Fine? Yep.
Guys, you know what? I didn't realize that these functions they have a CMOS level knob, and I would turn that down to 5 volts because he's up on 7. So this function generator, this big thing that you're going to get your clock out of, it has a CMOS
God, I
level.
feel the heat coming off this
I would turn that
laptop.
thing down to 5. You have to adjust it with your scope. You have to look at your scope.
We need to turn this on.
Yeah, I got 5 volts.
Yours is a moving. Oh, you have to push that. Oh, you have to push that. Yeah. It only works if you push the CMOS button, so we don't really have to have that pushed because it should give you 5. You can turn the CMOS off, and then that will give you. Also turn off duty cycle.
Who's going to 2?
Turn that off. That will give you a top.
And the red's going to 2. This one's going to 2.
I mean, you can play around with that duty cycle if you want, and CMOS level.
Cool.
It's more advanced than
Well,
what
we
we
need
were.
to. Now we just need to connect this to the ground. And that will be the same thing as this, man. Yeah. He's got 2 separate ones or something. Yeah, it's the same thing. Yeah. 2 wires in. Alright, so we have 5 volts, 10 hertz. Did you send over 40 pounds? No, yeah, it's on 5 volts. See, but I don't know. I mean, there's no. How do we know voltage? Check. We just dig DM and check it. All right, we got 5.2 volts. We got 5.2 volts coming out of the power, so we're good. Just had to verify with the DM. All right. Yeah. That's what we need to board the light on fire. Now we have no ground.
Ground.
Red box. Right now.
Around and run that down from there and the power.
Look at this. You gotta make sure you got
Everything
good
else is
hair.
set up with it the other way.
We don't have a ground on our switch. Yeah, so it's ground on there. Switch is below here. Excuse me. Thank you.
I keep trying to look at his to see if he's got everything placed.
I wonder how you read it off the budget.
Oh well. I said, I don't know what she's. This is hooked. Is this hooked to his hot?
Yeah.
No, it's the resistor.
No, it's not. It's hooked.
The resistor's down.
It's hooked on his,
right?
yeah. And then,
No, it's not.
so this one hooks on pin 2. And this one hooks on 3, looks like. Boom.
Yeah, this switch might be lined up with pin 1. I get power to the switch.
that?
Why is there no power? Well, the switch because we got to line up with pin 1, right? Because the resistor.
No, let me see. What you have to do is you have to put this pin on pin 1, and the others have to hang out past over here, not on those other ones. So
Okay,
that
so
one right
it's
there.
straight signal and then no signal. Ground needs to move up
Yeah. Yeah, and then the ground needs to move
to pin
to the middle of the switch. You see, because this yellow line needs to be free to toggle here. This needs to be free to toggle that with no other signal.
What's this other thing you got look to? Is this
What thing?
These other ones. Oh, never mind.
It's the same thing you've got.
I thought it was running around. How do I adjust the time on here?
Set.
How do I adjust the time?
Hit auto set.
There it is.
Yep.
1 volt. Now we need 5 volts. 5 volt reference. It's running at 10 hertz.
Well, we got a fast forward transform on there, right?
Hey, we got a problem.
he's only got one like that on his
See
second.
what we're doing?
He's got them connected to these things.
We should match it. Matching No, we can't turn it up. It's at 5 volts.
2 to 1, and then the others on the other side.
Right, but I mean, it should be the
Dang, I'm
same
not
height.
positive.
But watch. With the switch, boom. That's all it does is get sharp little points on it. Well, it matches up with sharp little points up here, but it's not really.
No, it's going from 1 to
What I did is
14, right? It's 14 right here, the first one.
No, first pin.
First pin's that one. It's going one, and then this one, and then this one after. So it's only on one row.
Yeah.
It's not good. So what I would do is take 5 over here, right? Over 10 times. Over 10 times.
That's what I'm saying.
Use this switch.
See, I thought it was just at 5 because that's how he was turning.
Right.
Down on the flat.
Alright, we have. Let's follow this. We have power to 14, right? We have a switch.
Oh, good luck finding a switch.
Yeah, this switch blows.
Well, I wish I had one when you say in, it just kept popping up. And there ain't any other ones. So I don't know what.
Switch is going to.
You know what? Let's get the push button switch. See, this one's big. Let's get the push button switch. Look at that.
I'm into one-legged switch.
There's a little push button switch.
You need one with 3 pins or 6 pins.
Hey. This is the switch. Oh, it won't fit there.
So you got
I
5.
mean, there's these.
That's what I was looking for. Hey.
The only thing we're doing is going to
Get around.
Oh, where's Brent? Oh, I don't think
6 pins on it, so a reach anything?
There's only 3 pins on that little switch. Alright, now we have to fix it. Pin 1.
5. 5.
Pin 1 and ground. Okay, got that. I'm into pin 1. Unless the switch is turned sideways or both or whatever. Kind of belt. See, this is still a switch.
Just go back until you get 5 volts. You know, keep, like, go here. Okay, no, I've got 5 there. Okay, got 5 there. Okay, got 5 there. And if it, it's kind of like a signal AC. So now I've got 5 here. Those cover things, those are really desirable. Like that. They really want to see, it's like, oh, this is not working. I don't know what to do. Like, okay, well, I don't know what to do. That's what they want to see. And then now if you put the switch in here.
Yeah, this one's working too.
Alright, we're still getting the same thing.
Yeah. And if you guys actually try to fix that.
Alright, pin 2 is connected to yellow. Pin 2 is connected to yellow. Nope. Alright, let me look at his real quick. Oh, yeah. Ground to ground, power to power. Power to 1.
People will jam it in things and then they'll hit it and get this thing.
We're not getting but a little jigs on the signal line.
Hang on. Hang on. The switch is blue. That's
Got something set.
we have the hertz. No, I mean that you can't have anything set wrong.
Oh, they're both set.
I mean we have a signal here. That's the only thing, you know. you take the switch out, it goes back to what it was when the switch was on.
Two more wires.
We just run it down. Anyway. Oh, wait. Check his connections with these one more time.
Okay, the blue probe is running at 3.
All right, let me confirm as you're saying this. All right, so blue I got running to 3.
Yep.
Black lead to 3.
Yep, the blue.
No, the
3.
black lead from the
He's got the red
from
on
the
one.
from the
or
clock.
2. He's got the red on 2, and then he's got the black on.
It's running the ground.
And then red's running the 2.
But from the clock is running the 2. The red from the clock is running the 2.
Right, and the black.
Black is running the ground.
All right, we didn't
this
have
one
any
is
ground.
like I thought. This one here comes off of.
There it is. We didn't have the black running the ground. We had the black running the 3 from the clock. There it is. All right, so what's the question? Set the control to 0. Okay, we have the control right there.
Control input is the pulse source to 100. Monitor the signal input. The grid output. The LEDs. Yellow LED. Always on. Always off. Flashing speed. Red. Flashing opposite speed.
What's it saying? Set the control input to 0. Pulse control 100. Monitor is the Y LED always on? So that's going to add an LED to Y. LED to Y. Y is the outputs. See, Y is the output.
Second one. And ground. Second one. And ground. Second one.
Make sure this LED works, first of all. You never know what these fucking things are. Yeah. You're going straight from power to ground. So that would be the line up.
How are you using the right legs? Because the long is supposed to be hot, right?
Yeah. Okay.
I just put it here.
The middle switch.
Yeah, the class is over in like 1 minute.
So,
I would start cleaning everything up.
Class is over. Shit, man.
Yeah.
It's way too damn fast.
First off, what I would do is test
Look, watch. Watch when I add the LED. Check this shit out. See how much it dropped the voltage? Because of the resistance in here? Watch this.
the resistance should be why is it got so much resistance and why is it dropping 12%?
I don't know. Well, we should have this one. Let's take the LED out and we'll just get signed off on this. Because I don't understand what it's asking. Set the control up at 0. I mean, we should see this. Hey, this is stupid right here. This little LED it drops at like 2.5 volts.
Really?
Yeah, just by adding it.
Come take a look at this.
Yeah.
I'll help you with something.
We got our signals.
Yeah, what the hell is this? I haven't even messed with this part right here yet.
Oh.
I got it turned down.
Yeah, hit this one. 20K.
Oh, it's 20K. I know it's 2.
20K. Yeah, I guess it's for 1 out of 10, I guess.
Okay.
You do it a lot.
Go ahead and turn off all the equipment, all the wire back, the part back.
I wanted to see this. Mr. Austin. Two questions. One, okay, we have the signal
Uh huh. It's working.
that you have.
That's good.
Okay, but I wondered why this happens.
What's that? What is that?
This is it's just an LED.
Uh-huh.
But when I hook up the LED from signal 3, look how much it drops in voltage.
Because you don't have a current limiting resistor. You have to have a current limiting resistor.
So how do you answer the question? I don't understand.
You have to put this over here. Okay, and then put a resistor from there to there.
Oh, okay.
You're loading the signal too much, basically.
Right, so it's dropping the voltage by like half.
Mm-hmm.
Okay. Yeah, and how do you answer these?
Set the control to 0 and monitor and the gate. Is the Y LED always on? Not flashing? It just, just when this is 0, then the output should be off, not flashing. And when this is 1, it should be on or flashing.
So off, on.
Yeah, that's how you answer it. Yeah.
All right, thank you.
Yep.
We put all our stuff.
Just put them back in the bin. Where'd you get them from? They used to be right here.
It's not there.
Does anyone know where the hand gates are at? Oh, okay. You guys can just put it over here. That's fine. It's good to get used to.
You got it running a little bit. Shut down again. I was like, oh my god. Yeah, I gotta do this.
Actually, I'll just put it back over here.
Click on it.
You guys can put the parts right there. Hey.
I'm just gonna run some wires real quick. And then this one. It hangs up over there. Just twist it up. It hangs up over there.